Hi, today I'm going over 2-5 solving systems of equations algebraically. This is a topic you've already done in Algebra 1, so hopefully it's a review or help you strengthen those skills of solving more than one equation. So there are two methods to solve them. There's substitution and elimination. Just like in outside of math, substitution means to my gosh, I went blank. Uh, put in a value for something else. Okay. I don't want to say sub. I want to say sub in the definition. That's not right. Use a value for another. I had one word definition earlier. I don't know what happened to that word. Elimination means to get rid of, and we'll be solving those. And so for these are two variable systems. We're going to be solving for a solution that is a point, x and y, or if it's a word problem, you'll have to explain what it means. So first we're going to start with substitution. One equation solved for one variable and in terms of another. So you solve for one equation for one of the variables, and then you plug that in to the other equation and solve that equation. So when you solve for one of the variables, you are going to plug in, solve for that variable, and then get your answer. Say you solve for x, then you're going to plug into your whichever one equation you want to use and solve for y. So when we do systems of equations, we get, again, we could have one solution, no solutions, or infinite many solutions. The examples they break up is one solution, then no solutions, but we don't usually assign things that way. You'll have to figure out how many solutions there are. So let's start with this first one. Here's equation 1, here's equation 2. Which one looks easier to get a variable by itself? Well, equation 2 looks a lot easier to get a variable by itself because it already has x there. So we're going to keep equation 1 how it is. And for equation 2, we're going to move the 2y over. So it's going to be a negative 2y minus 12. Here it is. So this is our new equation 2. EQN is my abbreviation for equation. So now we're going to get this equation 2 that's manipulated and plug it into equation 1 for x. So this is equation 1, and that kind of involves equation 1 and equation 2 together. So equation 2 is this now. So instead of x is equal to negative 2y minus 12. So we're going to plug that in. Now you are solving. So you need to distribute negative 16y. 8 times 12 is negative 96 minus 3y minus 1. Negative 96 is there. Negative 16 minus 3 is negative 19. Add 96. I get 95. 95 divided by negative 19 is negative. Let's think. 20 goes into 100 5 times. This is 1 less. So 100 minus 5 is 95. So it is negative 5. That is our y value. So if I have x and y, my y is negative 5. Now we have one value and we want to plug back into one of the originals to solve for x. And again, back to my original equations. Since these have all these numbers, this one looks easier to solve for x. So you want your original just in case there's an error there. So we're going to plug it into that second one. So everywhere there's a y, I'm going to put negative 5. So I'm going to get negative 10 there. Add 10. Add 10. That goes away. So I get negative 2 for x. and this is my point, -2, -5. You can substitute into the original equations. When you want to check, you want to go back into your first equation that was given to you. That is one way to do substitution. Another way to do substitution that sometimes people think it's easier, it's just up to you. I like looking at it and see what method works best for that. Sometimes there is none and you just have to pick a method. Another way you could do it is write each equation. I'm going to rewrite it over here on the right as slope-intercept form. So y equals mx plus b. The m doesn't really have to go first, the mx, but y equals y by itself and all the rest following. So let me do the first one. There's my original. The first one, I'm going to get -3y, move the 8x over, so it's -8x minus 1, divide by -3. Remember to divide each term by 3. I get y equals 8/3 x plus 1/3. The second one, I move the x over. I'm just going to move it again and get 2y equals -x minus 12. Divide by 2. Y equals -1/2, because that's 1/2 x minus 6. So now these two are my new equations, equation 1 and equation 2. Now, we are substituting. So since y equals this and y equals this, I could put those two things equal to each other and solve for x. 8/3 x plus 1/3 equals -1/2 x minus 6. And if you want to get rid of all the fractions, 3 and 2, I can multiply this by 6, this by 6, this by 6, and this by 6. So I'm going to stop here in a minute because I'm running out of room. But 6 divided by 3 is 2. 2 times 8 is 16. 6 divided by 3 is 2. 2 times 1 is 2. 6 divided by 2 is 3. 3 times 1 is 3. And 6 times 6 is 36. So you could solve for x that way. Sometimes people think it's easier to use substitution this way. Get y alone, set those two equal. Since y equals that, I could just plug that in over here. Up to you. All right, let's do a check. So looking at these two, this one looks really easy to get y by itself, so I'm going to change that to y equals 5x minus 3. Remember, the 5 changes signs when it crosses the equals. And I'm going to plug this in for the y right here. I'm going to get 3x minus 8 times y, but y is 5x minus 3, equals 24. 3x minus 40x plus 24 equals 24. Now when I subtract 24 from both sides, I get, I'm going to write over here, -37x equals 0. So the only value x could be is 0. 0 times anything is 0. So 0 is a number. 0 is a fine answer. It's okay to have 0. Now to get y, as long as you did this one right, you could use it here, but I'm going to go back to my original. So x is 0, so that goes away. So I just get y equals -3. And there's my solution. It's always a good idea to get in the habit of checking it in the original. So I know this works for the first equation. Now we could check it in the second one. So 0 makes that go away. -8 times -3 is 24. So that works. So the solution is correct. Now they say when there is not exactly one solution. So what are the cases for that? We could have -7 equals 8. That's not true. So there is no solution when you get something like that. Those lines are parallel lines. Or if you get 8 equals 8, Yes, that is true. So that solution are infinite solutions, which is a little different than all real numbers, because all real numbers is a number line, but we're using solutions because we're using any number for x and any number for y. There are two variables for this. So let's go to this one. This is already written y alone, so it's ready for substitution. So we're going to plug it in for this y, and so we're going to write 2x minus 11. I'm going to have to get my calculator out. 2 times 2.5 I know is 5. 11 times 2.5 is 22. What's half of 11? 5.5, 27.5. 11 times 2.5. Yep, negative 27.5. Then we're going to add 27.5. It doesn't really matter if you add or not. The reason they stopped is because of this right here. Negative 5x, that's my variable, x. It goes away. So we could not add. We get negative 27.5 equals 15, negative 15. It has no solutions because these are not true. Okay. So now we're going to apply the substitution method. And if you are in chemistry, you definitely are going to be doing stuff like this. If you're in physics, you definitely did this last year. But Miss Washington is preparing a hydrochloric acid solution. She'll need 300 milliliters of 5% hydrochloric solution for a class using a lamp. And she has a solution that's 3.5% and a 7%. How much of the solution should she use in order to make the solution needed? So she needs 300 milliliters. So this is a word problem to a system. We're going to be practicing these in class, but usually, well, first you need to say x is going to be the 3.5 solution, y is going to be the 7% solution. It could be whatever letters you want to use. You need two different variables, and so those are what we picked. But one equation is going to have to do with amount or quantity. And the other one deals with the percentage, or other ones, it deals with money um, or totals. Okay, so I'll show you more of those. But this is our first equation. This is our second equation. What this is saying is X amount of this solution. And remember 3.5, we moved that decimal place, divide by 100, move it back to spaces. This is a 7% solution. And we want 300 milliliters of a 5% solution. So this is quantity, percentage, quantity, percentage, quantity, percentage. Okay? So let's rewrite this one. We're going to move the y over, so it's negative y. We're going to substitute that in for x, negative y plus 300. Going to multiply negative 0.035y, 300 times that. Let me see, 300 times 0.035 is 10.5 plus this. So 7, 3.5, subtract it, we get this many y. Now we got to subtract the 10.5. Got 4.5. 4.5 divided by 0.035 is about 128.6. Does it say how to write the solution? No. Sometimes it say tenths or hundredths. So this is our y value. This is how much of the 7% solution we are going to be using. So then they plug that in to, or subtract it from 300 because we know we're going to have 300 milliliters. So this is the percent of the 3.5 solution. There's our, oh, they said 5.7. I rounded to 6. There's our X, there's our Y. That is 3.5 solutions are X, and there's our Y. Okay, that is substitution. I'm going to see, oh, I can't see the time to put a marker that is substitution. Now we're going to do elimination. So I'll try to put a marker in the video to say this is the start of elimination. Elimination. We have to get the same amount, the same quantity of a certain variable. It could be X, it could be Y, and then add the two equations together to eliminate one of the variables. Then we solve for one, and then we plug back in and solve for the other one. So here's elimination with one solution. Elimination, these two, looking at X and Y, we look like this would be great to eliminate because it's the same number, but we need, for elimination, we need one positive and one negative. So we need to change one of these to a positive in order for it to eliminate with the other equation. They chose the second one. It doesn't matter if you want to do the second one or first one. They chose equation 2. So multiply by -1, or what you do is just change the signs of everything. As long as you do everything, you'll stay equal. So I get 4x plus 9y is 23. This is my new equation 2. There it is. They wrote it underneath the first equation, equation 1, the new equation 2. And now you just add down. So the 9y minus 9y go away. 4 minus 2 is 2x. Negative 25 plus 23 is -2. If I divide by 2, I get x is -1. Now I have x. Now looking at either one, they don't look, there's not an easier one to solve for y, so you just pick whichever equation you want. They use the second equation. This is the original equation. So they're going to plug in -1 for x and get negative times the negative is a positive 4. So -4 minus 4. So that goes away. Negative 9y is -27. Divide by -9, I get y equals 3. So my x is -1, my y is 3. Okay. Going back to the substitution, sorry, I'm going to put a marker and then this. Word problems, you should write your solution, your final solution, in a sentence, not just a point. You should have a sentence putting it in context on what the answer means. All right. Now elimination. So we just had to multiply one equation here. Now we're going to have to multiply two equations. So this doesn't look good for substitution. Elimination could work. You could also do graphing for any of these, but elimination, we have 2, 3, 5, 4, and we don't want to worry about the extra numbers because we want to eliminate one of the variables. So I'm going to follow what they did, but you could multiply so many options. You got to have a negative and a positive. Since these are both positive, hopefully they worked on this one. No, it doesn't look like they did. Oh, they did 2 and 3. They worked on this. So 1 has to be a negative. They did it a little different. They said they got the same number and then subtracted, and when you subtract, you got to change the signs. I like multiplying by a negative, so I'm going to modify what they did. I would actually do it by the y's. I would multiply this by a 4 and all of this by a 5, distribute to all three terms, and then these will cancel because I have a positive and negative. But I'm going to go through what they did, which is a little different, to show you what they did and how I do it. So we have first equation, 2, so we want a -6 or +6 to start. Because the other equation is 3, so you just multiply the other equation by that number. So we're going to multiply by a 3 and get this one. We're going to say this is new equation 1. Then I'm going to do a -2 to the second equation. That way I don't have to worry about changing signs later. I have a positive and I have a negative, and we're done. So this is going to be a -6. This is going to be a plus 8y. This is going to be a plus 20. So this is my new equation 2. Now we're going to write them vertically and add down. So remember, they said subtract, which means you have to change it. So this is a -6, this is a plus, and this is a plus. So now I just have to add down. 20 plus 3 is 23. These eliminate. I get 15 plus 8, 23. 23 times 1 is 23. There's my y. Now we substitute into either equation. They chose the first. They put 5. I'm going to minus 5, minus 5. I get -4. -4 divided by 2, because this is divided by 2, is -2. So I get 1, -2. Last example, elimination where there's not exactly one solution. Again, you get something that isn't equal, but I'll go through it. So they changed the second one. Oh, this is a good one. So 18 and 6. This just has to be, 6 goes into 18. So if I multiply this by -3, it'll eliminate with that. Coincidentally, if I multiply by -3, it'll eliminate the y's also. So that's where the error, well, that's where they go away and you get something that's false. So I'm going to multiply all of this by -3. You can focus on the x, but you get -18x, -21y, and -6. Adding down, the x's cancel, the y's cancel. I get 0 is equal to 8, but it's not equal. So there is no solution for that. So those are parallel lines. Okay. All right. This is 2-5. Your assignment for 2-5 is 1 through 8, 9 through 14, 21, and 23. Let me know if you have questions. Thank you.